Well, hello, sixth grade. Welcome to what I believe for you is a Thor's Day. It's technically, though, while this video is being recorded, it is St. Patty's Day of 2000. No, 2000. What are we at? 2020? Oh, that sounds scary. Actually have no idea what year it is. We'll go with 2020. So, allow me to say Happy St. Patty's Day. Yay! Go Irish. L85, finding unknown factors. We've dealt with these ideas before. I've been front loading this for years, basically at this point, I believe. No, it says finding unknown factors. An unknown factor, unknowns in math lead us to algebra, and that's what you're looking at, an algebraic equation. 3n equals 12. Now, as you know, the direction for this will be quite clear. It'll tell us to just solve. Now, in the solving act, what we want to think about is our goal. And we'll often ask ourselves, what is happening to the variable? In this case, the n being the variable. Now, reminder of the goal, I think you already know it. It's three simple words. Yeah, you know it. Isolate the variable, right? We've done that before. And we're going to talk a little further about isolation a little bit later in this video. But right now, in order to isolate the variable, we always want to ask ourselves, well, what is happening to that variable? And hopefully you would conclude by looking at that what is happening is it's being multiplied by 3. So what I'm going to do is do the opposite, the inverse operation of multiply by 3, which is on 5 words or less, I'm going to divide by 3 on both sides. Remember, we're going to use the fraction bar to indicate division. I divide by 3 there, and I divide by 3 there. On the left side, as we know, we get n. Technically, it's 1n, but we generally will just put n. And then 12 divided by 3 is clearly 4. Now, I can box this up, but remember, as I'm boxing this up, I want to be able to check that. So what I can do is plug in that 4 for the n, and it would say 3 times 4 is equal to 12. That's something I believe in. In this, n equals 4 represents anyone? Yes, that's correct, my solution. And we've talked about solutions before, and there is a Pavlovian kind of response. If I ask you what a solution is, I always want you to tell me a kind of a set of words. And those set of words are simply the value of the variable that will make the equation. Do you remember that last word? It's kind of important. The value of the variable that will make the equation true. Because if I plug in that 4 initially into the first equation, it would be 3 times 4 equals 12, and that's simply true. So we are on our search for truth. Let's try another. This is your first book example. 5n equals 21. Now again, I want to ask myself questions like, hey, what's happening in the variable? And hopefully I would conclude quickly that it's being multiplied by 5. So in 5 words or less, I'm going to divide 5 on both sides. And so that's division by 5, division by 5. And then on the left side, as I know, I get my n. And on the right side, you're like, oh, should I turn it into a mixed number? But may I remind you that you are a sixth grader and we love our improper fractions. So no, we're good with 21/5. Now the question is, when I go to box it up, like that means I've checked it, right? And you might say, oh, well, I can't check fractions. Well, sure you can. Because all you're doing is you're going to plug it back into that original. So if we technically did it in written form, the checking, it'd be 5 times. I'll open up parentheses. Instead of n, I'll put in 21/5 is equal to 21. And then as you can see, I get some nice cross canceling there, 5 and 5. Well, 21 is equal to 21. So that would get my little check. Therefore, it's correct, and therefore I can box that up with absolute certainty. You're doing great. I'd love to move on. Let's press on. Here we go. Ooh, this is a toughie. It's got decimals. Hopefully you could say this properly, where you would simply say 600ths m equals 48 thousandths. What would we do? Well, we always want to ask ourselves what's happening to that variable. Hopefully we'd conclude that what's happening is it's being multiplied by 600ths. Therefore, I'm going to divide both sides by 600ths because that's kind of how it works. You know that. On the left side, I'll get my m. We know that. Now we got decimal division. We got to be careful here. I'm going to set it up over here. Nice and careful. There's my Long division algorithm, I know the 600ths is my divisor, the 4800 thousandths, oops, is my dividend. Now remember, we can't start dividing here. And this is one of these little skills I often find that, some sixth graders take to it quite well, some are kind of in the middle, some not quite yet. You gotta learn how to divide by decimals. And remember, if there's a decimal in my division, in my divisor, I'm not allowed to start. So I'm going to move that decimal over twice to the right to make it a whole number, if you will. And I got to do the same to that for 48 thousandths. And so once I've done that, there's my new decimal. I put it nice and clear. Then I ask myself the questions. I just kind of disregard the little bubbles and I say, hey, how many times does 6 go into 4? Nothing. And then how many times does it go into 48? Well, I know that that's 8. And then so 8 times 6 is 48. And I would subtract and I get a zero remainder. I'm at the edge. Therefore, I know that that's my quotient. And I could say that m is equal to 0 and 8 tenths. Or, sorry, sixth grader. M equals 8 tenths. Boom. Box it. Let's move on. 45 equals 4x. Hey, what are you going to ask yourself? Yeah. How are you going to respond? 5 words or less? Oh, I can hear you screaming it out now. Well done. Out from all the houses in Westchester and beyond, I can hear you screaming out, divide both sides by 4. And you should be. And if you did that, it would look like this. I'd get that X on the right side, nice isolation. Isolation meaning getting it by itself, at least right now, that's all it means to us. Maybe soon it'll mean something else. And then I don't need to do anything to that fraction. It's already reduced. And this could be my answer. However, Sexton does do stuff like this. They'll say, make sure your answer is in mixed number form. Well, I should know how to do that because 45 fourths is, 4 goes into 45. That would be 11 times with 1 left over, 11 and 1/4. Or maybe Saxon would say something like, turn your answer into a decimal. And you're like, well, I can do that too. So x equals 11 and 25 hundredths. I don't know. It kind of depends on what they ask. If they don't ask anything, guess what? This, my friends, is your answer. If they ask for a mixed number, I guess this would be your answer. If they wanted a decimal form, hey, that would be your answer. You got to give them what they asked for. All right, uno mas. This one's a little bit different, right? And you know what? Whenever it looks like this, you'll never hear me ask you what's happening to the variable. It sends us not down a rabbit hole, but it kind of sends us on a detour to ask that. So if it looks like this, I'll probably always say, hey, what's the quickest path to isolation? And let's talk about that isolation thing. What I'm noticing in this one is that this thing, which is actually called my coefficient because it's being multiplied by a variable, any number or value being multiplied by a variable is referred to as a coefficient. That coefficient is a fraction, and that's going to slightly change how I deal with this so that I can be very efficient in my math. So I want to talk about isolation for a moment. Usually we just always say that isolation is getting the variable by itself. It is. I'm not changing that. However, if we noticed before, well, it's never really by itself because it has that 1 attached to it. So if I say p equals 5, well, that's 1p equals 5. If I say t equals -2, guess what? That's 1t equals -2. So another aspect of isolation I think we could talk about is that when the coefficient, in this case the 2/3, when the coefficient, when you have a coefficient of, can you guess? It's if you have a coefficient of 1. And if that's the case, considering that 2/3 and something I learned about in another math place, I want to then think about that 2/3 and how could I make it 1? Well, this should lead us to a concept called reciprocals. You might remember that the definition of reciprocals are two values whose product is 1. So if I choose to multiply both sides by the reciprocal, in this case 3/2, what that's going to allow me to do is, one, get isolation, or it'll get me a coefficient of 1, because look at all the canceling that's going to happen. 3 and 3, 2 and 2. Well, those are all canceling to be 1, so technically it's 1x. Well, guess what? That's what I'm talking about. A coefficient of 1. That's isolation, right? And then on the right side, I have a nice cross-canceling here. That'll be a 4. Now 4 times 3 is clearly 12. And again, as I box that up, can I plug it in? You can. Should you? Well, if your grade's on the line, I definitely would be. Hey, almost 10 minutes. Hope you're well. Make sure it is Thursday, so you owe me homework, L85. And take care. Bye. See you soon.